Welcome. Today we're going to be talking about determining direct variation given an equation, a table, a set of ordered pairs, or a graph. We want to show mastery in class tomorrow by scoring at least an 80% on the exit ticket. Hopefully you grabbed the notes from me. If not, make sure you're writing this down on a piece of paper and bring it to class tomorrow with the practice problems that are in Google Classroom. Now, if we look at the notes, the big thing to keep in mind when it comes to direct variation, it is still a linear relationship. Now, we're going to call it a direct variation. It is when the ratio of the y-coordinate to the x-coordinate is constant. And if we think back to English and the word constant, it means it stays the same. You will see it written as y varies directly with x. What that means is every time x increases, y increases by the same factor. If x decreases, y decreases by the same factor. Now, just some tidbits of information for you to know. Direct variation equations always go through the origin. Every time. If it does not go through the origin, it is not a direct variation. A tip to help keep all the terms straight and all the equations straight. Direct variation is when you divide. They both begin with the letter D. It's just like slope. You're going to do y over x. It's the same thing as our m. Now, our constant of variation, and I know it's a little different to see it written as k, but that's your constant, is y over x. Same thing as saying slope. Our line, since it is slope, is y equals kx. It's the same thing as using slope-intercept, because if I talk about my y-intercept, it's 0. Well, I know that any number plus 0 is going to stay the same by the identity property, so I don't need to add it. So my equation would just become y equals kx. If we look at our examples, example 1 asks us to find the constant and then write the equation. Well, it tells us it's a direct variation, and direct means divide. So k is going to equal y over x. For my first point, I would do 4 over 1, which equals 4. My second point, check them all. 8 over 2 gives me 4. 12 over 3 gives me 4. And 16 over 4 gives me 4. So that means my k is equal to 4. Now, when I go to write the equation, it is y equals 4x. 4 is my constant of variation, and so that becomes my slope. It is times my x since it is slope. If we look at example 2, again, we still want to find of the direct variation, which means we're going to divide. I have negative 8 over negative 12, which is equal to 2/3. If I do negative 4 over negative 6, it's equal to 2/3. 0, 0 is my origin, so we know that works. And the last one is 2/3. So that means my constant of variation, or my k, is equal to 2/3. For my equation, I'm going to do k times x, which would be 2/3 x. Again, my k is just my slope, so it stays right with my x. Now, when we talk about finding the missing value, we always know that k is equal to y over x. So in this case, we're going to have negative 4 over 2, and in my second point, it is y over negative 6. If we think back to previous years, we've learned how to solve proportions when we have two fractions that equal each other, so set them equal to each other. From here, you're going to cross multiply. Negative 4 times negative 6 equals positive 24. I'm going to divide by 2, and I'm going to get an answer of 12. Now, if you weren't sure, plug it back in. If I plug it back in, negative 4 over 2 is equal to negative 2, and 12 over negative 6 is equal to negative 2. My k's are the same, so that's my correct answer. Again, in example 4, we're going to set up our 2 points. We have y over 12 is equal to 7 over 4. So again, cross multiply, we're going to do 7 times 12, which is equal to 84, divide it by that 4, and we get y is equal to 21. Again, and I'm going to have to erase my work because I'm out of room, but check yourself. If I do 21 over 12, that simplifies down to 7 over 4. My second fraction is 7 over 4. They're the same, so it works. Now, in example 5, it's written a little differently, but it's very similar to example 3 and 4. Start by creating your coordinate points. If y equals negative 18 when x equals 3, that's my first set of coordinate points. I need to find x when y is equal to 30. So then I'm going to set up my proportion. Negative 18 over 3 is equal to 30 over x. When I cross multiply and divide, we get an answer of x is equal to negative 5. Now, number 6 asks us that we need to use point A to plot two other points that are elements of the direct variation. The coordinates on these points must be integers, and that's important. If I look, point A is located at negative 1, negative 4. We know a direct variation has to go through the origin. So, one of my points can already be 0, 0. Well, if I use my origin as another point, I can find my slope. So m is equal to negative 4 minus 0 over negative 1 minus 0. I get negative 4 over negative 1, which equals a positive 4. From here, I can use that just like we did during our slope equations and graph more points. Well, I have a positive 4 slope, so I'm going to go up 4 and to the right 1. I can keep going up 4 to the right 1. So from here, I have the point 0, 0, I have the point 1, 4, and I also have the point 2, 8. Now, it did just ask for 2 points, but those are 3 different points you can have. We can also, if we go down 4 and to the left 1, 2 negatives make a positive, and use that. We could have negative 2, negative 8. So in this case, it's 4 different examples. It asks for 2, but I wanted to make sure that you saw how you can find all the different examples. And again, keep in mind when you do these, it's still using slope, so it's still a linear equation. Your points should fall in a straight line. If I were to connect all these, they do make a straight line. If your points don't make a straight line, you probably counted incorrectly on your slope, or you went in the wrong direction, so double check your work. Flip your paper over to the back. You can begin working on the practice problems. Please bring them and any questions you have to class tomorrow. Looking forward to seeing you then.